Hey everyone, welcome back to another RPG framework tutorial. Today, we're adding the ability to drop items from the inventory, giving players full control over their loot. Whether you want to remove unwanted items or create a trading system, this feature is essential for any RPG. Also, the results are in. Our last poll on the next character leveling system tutorial is finished, and the winner is Dark Souls style leveling. So, stay tuned for upcoming tutorials focused on that system. Now, let's jump in and start building. First, we need to define drop item functions in C++. Open Visual Studio Project and find RPG Item Interface header. Define drop item function as new blueprint native event. Go to the RPG inventory component header and do the same. Now go back to Unreal Editor and compile. After compile is done, we can start with implementing drop item functionality. Open Inventory Blueprint component. Implement drop item event. Here we should check if provided index is valid like we did in event use item. Additionally, we need to ensure that item we're dropping is not equipped. We can check this by using gameplay tags. If everything is good, we can move forward by spawning item to the map and removing it from the inventory. For spawning item on drop, I'm going to create separate event. This event should receive item index as input parameter. Let's implement spawn item event. Here we need to check if item we are dropping is spawnable item. If yes, we should spawn it on the map. Otherwise we will only remove item from the inventory without spawning it. For spawn location, I'm going to find location on the ground in front of inventory owner. Now let's add new input action for dropping items. Duplicate use item input action. Rename it to IA, drop item. Open in game menu mapping context and assign some key to drop item action. Now go back to inventory component and call function drop item when drop item action has started. Now we need to update inventory widgets. Open Item pop-up widget and add one more label for displaying key that is related to drop item action. Also, you should do this in Equipment pop-up widget. Additionally, we need to update Equipment Grid widget. Here we need to add binding to inventory component event on item removed. When item is removed, Equipment Grid should be updated. Let's test this. Open inventory and try to drop some item. You should see that item count is decreased. When you close game menu, you should see that item you have dropped is spawned in front of the player character. Also, you are able to drop weapons that are not equipped. However, you can see that when you drop some weapon, it will be spawned like this. You can fix this on multiple ways. You can adjust position of weapon static mesh in weapon actors. You can change pivot location for each mesh. But if you already created a lot of weapon actors, this will require some time. Another thing you can do is to utilize function drop item that we defined in RPG item interface. First, go back to inventory component. Call drop item function on spawned item. Now go to the weapon base blueprint. Implement this function. Here I'm going to update actor location and rotation based on static mesh bounds. Let's try to drop some weapon now. As you can see, axe is now positioned better. You can try with other weapons too and adjust location if needed. But there's one more problem I would like to cover in this tutorial. If you drop multiple items while standing on the same location, all items will be spawned at the same point in the map and overlap each other. Again, there are multiple ways to solve this. The most basic one will include collision checks when you drop item. Another one can include using physics engine to prevent overlapping. But I would like to teach you how to use environment query system for this purpose. Environment query system is a powerful tool for getting locations based on some conditions. However, for this particular scenario, there is no built-in generators and tests we can combine. We need to find locations in front of inventory owner, but these locations should not be occupied by other items. But don't worry, I'm going to show you how to create your own points generator by utilizing as much as we can from built-in generators. For this purpose, I'm going to create new environment query generator as child of cone generator. You can find all the code needed for this generator in description of this video. Let's start with header file. Copy header content and paste it in your project. Here you can see that we are going to override project and filter navigation points function. Also, you can see some parameters we are exposing to environment query editor in order to control things like type of actor we are looking for, search radius and minimal safe distance at which we are allowed to spawn another actor. Now copy constructor implementation. Here we are only set default values for generator parameters. Now copy implementation for project and filter navigation points function. For this implementation, we will need to include these engine modules. Now let's see why we are overriding this function. If you open cone generator class, that is parent of this class, you will see function generate items. Go to the implementation of this function. You will see all the heavy lifting that is done to generate points in cone around the query actor. It will be obvious that this is the function we should override. However, if you go to the end of this function, you will see these two functions are called as well. Although you can override any of these three functions, it will be the safest to override project and filter navigation points. At this step, no points are stored as generator output. Go back to our generator to explain implementation. First, we should call parent function to ensure that it does its job. Then we are searching for all actors of the provided class that are in defined radius and store its locations to a new array. At the end, we are looping through points array and check if there is some points that are close to actor locations. If yes, we are removing that points from the array. Now go back to Unreal Editor and compile. When compile is done, create new environment query. You should be able to see our new generator here. If you see two of them, make sure to restart Unreal Editor before you continue. This is sometimes happening. I believe that this is some bug with hot reload system in Unreal Editor. Once you restarted the engine, add our custom generator to query root. For searched actor class, select spawnable item class. This will ensure that spawnable items will not overlap. You can play with other parameters, but I have found that these values work well for finding item drop location. Also, make sure to change trace mode to geometry by channel and select visibility channel. This will ensure that all points are projected to the ground or at the top of world static meshes. Now add distance test. For test mode, select distance 2D. For filter type, leave range. Set min value to 100 and max value to 250. Also, change scoring equation to inverse linear. This will help us having better score for locations that are in some mid-range from querier, as you can see on this graph below. Now we should use this query. Go back to inventory component. Find spawn item event. Go to the end of it. Here we need to store dropped item to new variable. To run environment query, we will use run EQS query function. Select our new query. For querier, send component owner. Leave single best item mode. However, this function is asynchronous, meaning that it is not blocking until query is finished. Because of that, we need to bind new event to onQuery finished. When query is finished, we need to ensure that query status is success. If yes, we can get query result as locations. In our case, this will return only one location. so we can use it to set location for last dropped item. Make sure to use validation get before you call this to ensure that last dropped item is valid. Let's try this now. Open Inventory menu and drop multiple items. When you close menu, you should see that dropped items are not overlapping like before. Also, you can try to drop items when player is close to a table. Some items should be placed at the top of it. Now your inventory system fully supports dropping items, adding more flexibility to player interactions. With this feature in place, you're one step closer to a complete RPG experience. If you found this tutorial helpful, don't forget to like, subscribe, and join the community on Discord. Special thanks for my Patreon supporters for making this possible. See you in the next video.